Hello everyone, this is Gao Jian from Tsinghua University. Today we will present a tool called VulSeeker. It's a semantic learning-based vulnerability search tool for cross-platform binary. Clone-based search method is one effective way to find known vulnerabilities in binary programs. Though many related tools have been presented, their performance in cross-platform binary search is limited. The ideal clone-based vulnerability search tool should meet the following three requirements. The vulnerability search method should be universal and can be applied to binaries of different platforms such as different architectures. The proposed tool must be immune to structure differences, can't be seriously affected by the control flow structure. In addition, a low computation overhead for complex large-scale binary is required. Our tool meets the above three requirements through labeled semantic flow graph construction and function semantics generation based on the semantics-aware deep neural network model. Our demonstration has two main parts. First, we present the architecture and the workflow of VulSeeker. Then, we demonstrate the basic usage of our tool. This is the architecture of our tool. Its input is two binary functions from the target program and the vulnerability database respectively. Firstly, our tool constructs the labeled semantic flow graphs, integrating the control flow graph and the data flow graph for the two binary functions. The figure shown in the right side is an example of labeled semantic flow graph. The edges labeled 0 and 1 represent the control flows and the data flows respectively. Then it extracts 8 types of lightweight instruction features and encodes them as a numerical vector for each basic block of the labeled semantic flow graph. Function semantics is generated by feeding the numerical vectors of basic blocks within the function to the semantics-aware deep neural network model. Finally, our tool outputs whether the target binary function is a vulnerability based on the similarity of embedding vectors of the two input functions. Next, let me demonstrate the basic usage. First, we put the programs to be searched in the search program directory. Then we open the config.py file and modify the parameters that point to the IDPro installation directory. Next, we run the command.py file to generate the labeled semantic flow graphs and extract initial numerical vectors for basic blocks. In the features directory, we can see that 3 kinds of files are generated. Due to limited time, we interrupt the running of this file. The file ending in CFG stores the control-dependent edges of the function. The file ending in DFG stores the date-dependent edges. The file ending in FEA stores the initial numerical vectors of basic blocks. Finally, we take the CVE 2015-1791 vulnerability to conduct the search task. We execute the search by list VulSeeker.py file to obtain embedding vectors of functions and get the function list in descending order of similarity scores. In the output window, we can see the function name, the item to which the function belongs, and the similarity score between each function and the vulnerability. We can also see more detailed information in the CSV file. Column A records the function name. Column B is the average similarity score between the corresponding function and the vulnerability function with 48 compiled versions. These versions contain different architectures and compilers. The other items after column C are the similarity scores between a particular version of the vulnerability and the corresponding function. That's all. Thank you very much for watching our demonstration. Our tool and more details can be found from this website.